Today I'd like you to turn to describing distributions. So go ahead and open up your study guides and let's turn to the notes on describing distributions. Now, let's first of all talk about the types of distributions. When describing the shape of a distribution, there are four common shapes that occur quite frequently in statistics. These four shapes here can be defined as graphs that are symmetrical, distributions that are uniform, graphs or distributions that are skewed, and once again graphs or distributions that are bimodal or multimodal. So when talking about the shapes of the distribution, shapes of distribution usually and typically fall into one of these four categories. Now let's begin to talk about the shapes of distributions being symmetrical. Symmetrical distributions basically refer to data in which both sides are more or less the same when the graph is folded vertically down the middle. Many distributions appear to be symmetrical in nature, and later on we're going to talk about one in particular, the normal distribution, that can be defined by a bell-shaped curve. A bell-shaped symmetrical distribution is a special type of symmetrical distribution having a center mound with two sloping tails. Typically, when we talk about distributions being symmetrical, we are really talking about them being approximately symmetrical. In reality, no distribution tends to be perfectly shaped. There are some times when that can occur, but for the majority of times, distributions, when we talk about their shapes, are approximate to one of the four shapes we described earlier. Once again, we'll spend a lot of time studying the normal distribution, which is a symmetrical shaped bell distribution. Many things occur in statistics with normal distributions. In the data, we talk about it being approximately normal. Now let's talk about uniform distributions. Uniform distributions refer to data in which every possible outcome has an equally likely chance of occurring. The frequency or occurrence of each class will be approximately the same. Uniform distributions are roughly rectangular in shape, and once again, it does not need to be a perfect rectangle. When a distribution is labeled uniform, we usually refer to the data distribution as approximately uniform. For instance, the roll of a die. If we were to take a look at the number of occurrences of each roll of a die after rolling so many times, we would expect our outcomes to be about the same for a 1, a 2, a 3, a 4, a 5, and a 6. And if we graph that distribution, it should be pretty much uniform in shape, having a rectangular distribution, because every outcome had an equally likely chance of occurring. Next, let's talk about skewed distributions. Skewed distributions refer to data in which one side or tail area is longer than the other. We refer to a direction of skewness when describing graphs that are skewed. If a graph has positive skew, its right tail is longer than its left tail. We sometimes refer to this shape as right skew. For example, in the box up there on the top, we see that we have a right skewed or a positively skewed distribution. The tail area is longer to the right. If a graph has a negative skew, its left tail is longer than its right tail. So once again, here is a negatively skewed distribution, and sometimes we refer to this as a left skew. This can be used interchangeably. We can either call the skewness positively skewed or negatively skewed, or we could call the skew being right skewed and left skewed. It does not make any difference. When distributions are skewed, we see that the majority of data falls to one side, and we have to capture points that sometimes can be considered outliers, where the tail has to grasp those points. And so we don't have much symmetry to the distribution because we have some observations that are what we consider to be in the tail areas. When that occurs, that's going to be where the direction of skewness occurs. Okay, let's talk about bimodal and multimodal distributions. Now, bimodal distributions refer to data in which two classes have the largest frequency and are separated by at least one other class. Typical bimodal distributions occur when we mix classes. For instance, if we mix gender and maybe one of